So when we're taking a look at this polynomial, show me with your hands, because there's a power of 4, what the behavior of the graph should be. Yes, both hands should be up. And how many roots should I have if the power is 4?
4.
So I'm not done until I have 4 answers. Okay? So when I'm doing this, some of you guys get excited because you found one, but then you're not able to find multiplicities, and I'm going to show you why. Because some of you guys are making it much harder than it needs to be. Noah, can you move your chair, puppy, please? So what I want us to take into account is everybody in here is pretty masterful at factoring by this point. So use it to your advantage. Instead of doing synthetic division 30 times, once you find one answer, you're going to be able to find the roots quite simply. So if I have x to the 4th minus 6x cubed plus 32x, you already told me the first thing that we're going to do is take out that x. So I have x cubed minus 6x squared plus 32. A lot of you missed the first root already. What did we already find? A 0 right there, because what you're really telling me is this is equal to 0 and that is equal to 0. You're saying, Miss Riad, x is equal to 0 and x cubed minus 6x squared plus 32 is also equal to 0. The problem is, I don't know how to factor that. We can't. So I need to use my P's and Q's. But here, you've already found one root. So when you do your P over Q, I saw people doing P over Q on the original problem. Why? You already found one of them. Do it with this part, because you already found x equals 0. No, are you with me? Now we're going to do P over Q for the secondary trinomial over here, which I saw walking around. Pretty much everybody has down. Everything that factors into 32, so most of you guys were able to get that quickly. Plus or minus 1, 2, 4, 8, 16, and 32. Now this part, I agree, is the most tedious part. It might be a little annoying, but it's not the hardest part, is it? Synthetic division? No. Use it to your advantage. So here I'm going to try some numbers and see what worked. Brennan, which of these numbers worked after you tried it? 4. All right, so look what he did. He tried the 4. He plugged in 1, negative 6, and what did half of you forget? 0. The 0. Don't forget that. And then a 32. Because remember, it has to go in order, right, Moon? Power of 3, power of 2. Whoops, where's power of 1? I need to make a placeholder for it. And then the 32. So we're going to do synthetic division. Drop it like it's hot. That's 4. Negative 2. It's negative 8. Negative 8. And there we go. Now, many of you at this point started making it unnecessarily harder by just continually using synthetic division. Why? Sean, are you with me? This is your remainder. This is your constant. This is your x term, and this is your x squared term. You know how to factor that. So what does this become? X minus 4 and x plus 2. So here we go. Look how, seriously, something that right now probably took you 15 minutes. Do you see how by January this probably take you like 4? Maybe even less. Because look how many we have. Ready? 1, 2, 3, 4. That's my 4 zeros. Now what do you notice here? This root is 4 and this root is 4. You have a multiplicity at 4, right? So if I ask you to list the roots, I have x equals 0, x equals negative 2, and x equals 4 with the multiplicity of 2. Whoops, sorry. Those are my roots. Remember what the first thing I asked you is what's the behavior of the graph? So you know the two ends are going to be face up. So all I have to do is plot my points I have a point at 0. I have a point at -2. And I have a point at 4. Ms. Riad, you said I have 4 roots. I only see 3 numbers. Yeah, one of them's a multiplicity. So it's going to go boop, boop. Which one is that going to be? The 4. So the first thing you always have to do is tell me the end behavior. You just told me it did this. So that's the first thing you do on your test. Just draw your arms because you know that's what's supposed to happen. Now, this -2. Is it a multiplicity, yes or no? No, it only shows up once, right? It's an odd multiplicity. It only shows up once. So that means it's going to go through the -2. It's not going to go boop, boop, off the -2. Are you going to go through the 0 or bounce off the 0? Through. Why? Because it's not an even multiplicity. Be careful. I didn't say not a multiplicity. I said it's not an even multiplicity. What the heck is the difference? Even multiplicity means there's 2 of them, or 4 of them, or 6 of them. Brandon, no, let me lose you, babe. Or 8 of them. It's an even paired number. Tomorrow I'm going to give you one on the warm-up with an odd multiplicity. Let me show you that in a second. But let's just get through this first. So is it going to go through the 0? Yes? And then what's going to happen at the 4? It's going to bounce up. And there's your graph. Or you can plot 1,500 points, which probably isn't what you want to do. Any questions on this? Now, I think where I lost some of you guys is 20 seconds ago when I was telling you about the even versus odd multiplicity. Tomorrow, I might give you a problem where it's x minus 1, x minus 1, x minus 1. Is this a multiplicity? Yes. Multiplicity of what? 3. 3 of them, right? The answer is 1, yes. But it's a multiplicity of 3. So is this going to go boop, boop, or is this going to go through? This is going to go through. So when it's an even multiplicity, it bounces off. If it's an odd multiplicity, it's like boop, boop, but then it goes back down again. Everybody with me? Questions? Yes, babe. How do you find which, these down here? You plot points. Great question. That would be like the maximums and the local maximums and minimums. You plot points. So this is between 0 and -2. What do you think is a smart number to plot? -1. And you think you should plug it in by plugging in points? Don't you guys, you've learned that synthetic division is the homie, right? You plug in -1 and it's just done. This is section 1.2, empirical rules. How many do we have, Ben? Of the sheets?
39.
39?
Yeah.
Oh, nice. And then just start gluing them on when you're done, Ben.
All right. Do you know who this is?
Empirical rules and distribution. The name's not on the second page?
No.
I'll figure it out. Tonight's homework is page 242, numbers 3 through 8. Literally a joke if you don't do the homework. Let me show you what we're doing on tonight's homework. If I give you an example where I tell you that the mean is 75.75 and the standard deviation is 0.03. So for those of you guys who are not fans of decimals, just think of it as money. Pretend the mean is 75 cents and the standard deviation is 3 cents. So let me explain what that would mean realistically. So imagine I'm shaking your hands at the door and I'm going to give you guys 75 cents average per person. Does that mean every single person gets 75 cents? No, it's average. Some of you might get 80 something, some of you might get 60 something, but on average you will get 75 cents. Now what does this mean? This 3 cents? Well, this is what I'm going to show you after we do our graph so you can see what we're looking at here. So go ahead and draw your axes. I always like to draw the bell curve first. That way my bell is symmetrical. Sometimes when I draw the mean and stuff first, it's all lopsided. What number goes right in the middle? 0.75. Very good. Now, when we ever draw a bell curve, we always draw 3 standard deviations to the left and 3 standard deviations to the right. We hardly ever do more than that. So all that means is you're gonna do 1, 2, 3, 1, 2, 3. And since the standard deviation is 3 cents, you're just gonna add 3 cents, add 3 cents, add 3 cents. So 75 cents plus that 3 cents, this is gonna be 78. Then we're gonna add 3 cents, and that's 81. And we're gonna add 3 cents, and that's 84. If I added 3 cents to the right, what do you think I'm gonna do to the left? Yeah, so we're gonna subtract 3 cents. Subtract and subtract. Let me tell you what this means realistically. Let's say Manu comes in and I give him 75 cents. Then Priscilla comes in and I give her the 72. Then another person comes in, and so on and so forth. And this whole area represents 36 of you somewhere on this graph. Remember back in the day when you guys used to do bar graphs? So there would be like a bar graph like this, and I need you guys to do this with your highlighter. It would be a bar, and then another bar, and then another bar like this. Remember that? So if there was like 7 people that got this amount, you would color in the bar. You remember this? And then 8 people got this, and then 6 people got this, and so on and so forth. Everybody with me? That's what a bell graph is. That's what it is. This bell curve is the top of your bar graphs that you used to do back in the day. But now we're too sophisticated. We don't need to do bars. We don't even need dots. They're like, oh, we don't even need dots. We're going to just throw a bell at them. And you can figure it out. And it kind of makes sense because you don't really need the inside. You just need the behavior of the curve. I mean, that's all you really care about. So somewhere in here is how much money you got from me. Notice that there's going to be people all the way over here getting 66 cents. And there's going to be some people getting 84. But where's the majority? Right here. What we call within 1 standard deviation is the most people. Within 2 standard deviations, even more people. But the least is within 3 standard deviations. Do you guys see why now we as statisticians, we don't go to 4th, I mean, look how ridiculous that would be. The 4th standard deviation is almost unnecessary. So conventionally, we just stop at 3. So today, for tonight's homework, you're gonna have to draw me this bell curve. You're gonna have to understand and tell me you understand that the mean always goes in the middle. And then how do you create the deviations? Well, it's based on the standard deviation that they give you. Pretty easy? Okay, let's do another one. Example 2. What if I told you that the mean is 40 and the standard deviation is 1.5? Same thing. You start with your bell curve. Again, your bell curve doesn't have to be particularly thin or skinny or high or low, but as long as the middle is the mean. We're always going to go 3 standard deviations above, 3 standard deviations below. Now I'm just testing if you can freaking add and subtract. Can you add 1.5 correctly to each one? So 40, this would be 41.5, this would be 43, and this would be 44.5. Do the bottom half for me, please. Take out your calculators, please. What'd you guys get down here? Yep, 38.5. This should have been 37, and this one should have been, yep. And that's what you're going to do on tonight's homework. You're going to highlight the mean. doing it one more example in an Adoyo. What if I ask you to represent a region above or below the mean? So what if I say identify the region that represents 2 standard deviations below the mean. So what you're going to get on tonight's homework is you're going to get a bell curve. They're going to give you a mean. And then they're going to put 3 tick marks to the left and to the right. And all you have to do is shade in the region that represents what they asked. Well, this is 2 standard deviations below the mean. So here's the mean. Here's 1 standard deviation. Here's 2 standard deviations. And now all I have to do is shade this in. Look how pretty that is. Here's your doyo. Identify the region. Am I going too fast, you guys? Identify the region within 1 standard deviation of the mean. What would that look like? Let me see if your English teacher will be proud of you. You know what the word within means. I'm a writer too, so let's see if you can decipher. Carlene, what did you guys shade in? Huh? Just one side? So if I ask you to stand 1 foot away from me, could you only have to stand to my right? You could stand on my left, right? So if I'm within 1 standard deviation, I should have colored both sides. Okay? You should have colored both sides. So you should have something like this. And that whole thing should have been colored in. Raise your hand if that's what you got. Good. One more check. What about if it says, English majors, more than 1 standard deviation above the mean? Don't yell it out. More than 1 standard deviation above the mean. You ready to tell me what you would shade in for more than 1 standard deviation above the mean? Noah, go.
So what you would do is you count 1 standard deviation to the right of the mean, and then you color everything to the right of that.
Very nicely said, sweetheart. You would start at 1 above the mean. You're not going to start here because this would be more than the mean. More than 1, not including the first. Buddha, who's there? Yes, babe.
So would you shade it up to the 3rd standard deviation?
Correct. Because conventionally, we only speak through the 3rd deviation. We do not really go past the 3rd deviation. Great question.